So if there's any issue during the presentation, so that you can access to them directly and to display the slides. This is the Jabber room. I don't know if if there's participant there. So if there is someone who would like to do Jabber scribe, please relay any, I would say, question that you have here in the meeting. This is a recap of the current active drafts we have in the working group. As you see, there are many documents that are active, but unfortunately we cannot go into all this draft because our focus will be mainly on the requirement and the architectural document, mainly to understand and to have a common understanding of, I would say, what we are doing here in DRIP and what will be the requirement of the solutions that we will be designing. So this is why we have designed the agenda to be structured into two main items. The first one, which will be the discussion of the requirements, and then there will be a discussion about the architecture. The time budget we allocated for, I would say, for the both slots include the discussion and I would say, the presentation that will be made by Stewart. We don't need to wait until the end of the presentation to raise the questions and to meet your comments. So please. Don't hesitate to interrupt and to raise your question and comment. We would like to have some discussion and interactive discussion between during the presentations, because there are issues that will be raised by Stewart in both presentations, and we would like to have more feedback from you and also suggestions and for the next steps. Then we will have I would say, 5 minutes for the open mic if there are any issues or any point that you would like to share with the group, and before closing the meeting. Is there any comment about the agenda? If there's no comment, I will, Stewart, the floor is yours.
Okay, great. So. Daniel, I assume you're going to run the slides from your screen and I'll just talk?
Yes.
Okay, next slide. So this is the big picture into which we need to fit. Notice center right, the UAS service supplier, the USS, that's kind of the center of the world with regard to larger systems that incorporate unmanned aircraft systems. And there's lots of interfaces, and standardization of all of them is ongoing. In particular, note that there will be more than one USS. Each USS will support more than one UAS operator, and except for hobbyists, most UAS operators will have more than one UAS. Next slide. Okay, so the key standard that's out there right now, which was published in, I think, February and balloted upon this past November, is from ASTM. It standardizes two types of remote ID, broadcast and network. The main point I want to make about broadcast is it is direct from the aircraft over a data link, not over a network, whereas network remote ID can be from any part of the unmanned aircraft system, most typically the ground control station, and it is via specifically the internet. And it's a 4-node, 3-hop process. It goes from the UAS to the network grid service provider, from the network grid service provider to the network grid display provider, and from the network grid display provider to the ultimate client. The only fully specified interface there is between the service provider and the display provider. Unfortunately, in the United States, the FAA is not even recognizing the display provider as a distinct entity. Also note that in both broadcast and network, ASTM has specified the framing of not very many bytes of authentication data, and there is no further specification of security mechanisms. Next slide. A lot of this obviously is just review. For those of you who've seen it before, I want to go through it real quickly. This is the obvious broadcast use case. Next slide. This is the slightly less obvious network remote ID use case. If you look at the middle tier, you'll see that USS A is acting as a network grid, what ASTM would call service provider for the first batch of UAS operators in the lower left. It is also providing display services to some folks, whereas USS B in the center is only acting as a network remote ID service provider, and USSC over on the right is only acting as a network remote ID display provider. Next slide. Okay. This shows the European and two different sets of US rules matrixed against the broadcast and network modes of ASTM. Our gap analysis at the bottom, the 4 key gaps. The FAA's NPRM says that remote ID is an enabler of various and sundry other things, whereas ASTM says no, remote ID is a security standard. It does not meet a high enough bar to be a safety standard, such as DAA, detect and avoid, to avoid collisions amongst aircraft. The NPRM calls for error correction. ASTM doesn't have it except in the special case of Bluetooth 5. NPRM calls for cybersecurity, whatever that means. They do specifically say we need both integrity protection and authenticity protection. ASTM standard only gives you framing for those bytes. And then everybody says protect operator privacy, but nobody tells you how to do it. And everybody broadcasts the pilot's ground control station location in the clear. Next slide. Okay. This particularly highlights the idea that an observer will get a remote ID and then we'll do a query into some to-be-defined registry with to-be-defined access control mechanisms to get data about the UAS and its operator. Next slide. This is our top-level set of meta, if you will, requirements on our approach. We believe that remote ID needs to be immediately actionable, which means the information needs to be trustworthy. Ideally, it should allow an observer to determine whether they trust the operator, even if the observer doesn't have, at the moment of observation, internet connectivity. It should enable the observer to reach out and touch the pilot and say, what are you doing there? I need you to exit that airspace because something has happened and it's no longer safe for you to be there. And privacy's got to be maintained if it's not forfeited. We want to complement existing external standards. But those external standards don't, well, the reason we're doing this is because those external standards don't answer all the necessary questions. We want to leverage existing internet stuff, and we have a stretch goal of going beyond operator self-reports. In UTM, the Unmanned Aircraft System Traffic Management as envisioned in the US, or USpace as envisioned in Europe, tracks are just self-reports from operators, and operators can lie or simply be wrong, or their hardware or their software could be malfunctioning. It'd be really great if we had some sort of independent confirmation or refutation of those self-reports. Next slide. Okay. On the left, that little stick man called the pilot/operator. There's a lot of things, a lot of entities that will often be identical, or if not identical, at least co-located. Likewise, over on the right, registry, there's a lot of functions that will be offered by the same people in more or less integrated fashion. And there's going to be other things in play, but we can't make remote ID depend upon a lot of other things, such as supplemental data service providers. However, we can enhance what remote ID does using these supplemental data service providers. Next slide. Okay, now we get into the real subject for the day. Requirements for DRIP. The first and most fundamental requirement is if I claim that my ID is Stu or 123, how do I prove that I, the guy who is sending messages right now, is really the owner of that ID? Second, I send a lot of messages beyond just who I am, the basic ID message. How do we bind all of those other messages to the identifier that I claim refers to me? Third, how do I prove that this identifier that I'm asserting is mine, 123, is in some registry, and specifically, which registry is it in? Does anybody have any questions of clarification on these before we move to the next batch? Can anybody even hear me?
I have one. So, just to interrupt. So, before we go to the discussion, the clarification, I would like to make sure everyone has been aware of the not well. So, I'd like maybe Med, could you could you see could you show the not well to make sure everyone get? Yeah. So, in case you're not aware of those way to proceed, please have a look at the not well, and then the discussion can go on. It's only an administrative thing, but it's important for the way we operate. Thank you.
Thank you, Daniel. This is Eric. Thank you for this.
Stu, Bob Moskowitz here. On Gen 1, you said the word that you made a personal me in terms of identifiable. Need to be clear that it's the UA we're talking about as being identifiable, what you have there, not the UAS. There is a distinction there, and sometimes when we're speaking, we tend to be a little bit theological, but we need to make it clear that we're talking about that this is the device identity, not necessarily the operator identity.
Yeah, thanks, Bob. For some reason, the documents all refer to it as a UAS ID, the documents from FAA and ASTM and so on. But if you then read the fine print in the documents, it makes it very clear that the ID is mapped one-to-one to each unmanned aircraft. And if an operator has multiple aircraft, each one of them will have a distinct ID, whereas the operator will also have an ID. Currently in the United States, I'm not clear on Europe, UAS operators get a registration number that is unique to the operator, and they put that number on each of their aircraft. But that will all change with the publication of the FAA's final rules sometime this fall. Any other questions on these first three general requirements? Okay, moving on. Next slide. Yep.
Sorry, it's Saulo from ICAO. Just in aviation, we normally talk about target level of safety, at least minimum levels of safety. Do you have an idea in terms of authentication, the chances or the probabilities of this authentication being not compliant, or say, let's avoiding messages like the replay attack or spoof or something like that? Do you have an idea on the probability of this authentication not happening correctly?
So at the requirements level, we have not found any external requirements from regulators or other SDOs on how low we need to make that probability. We can, of course, compute the probability that any of our proposed mechanisms would offer.
I would also say that if you had to put all of our documents together that we've drafted so far, but we had that probability down to 0 inside the total structure. The registry is the important part, not just the IDs. So that all ties in together, and we'll need to make this a little clearer as we proceed after we get past the requirements. But yes, in the requirements, there's no clear distinction of how unique, how reliable. We believe we hit 100% reliability.
Okay, thank you. I'll take that as a proof that the message is not a replay or a spoof for us.
Well,
okay.
The messages as designed, when you're trying to work on Bluetooth 4, you cannot do that. You have to go into particular Adam's auth document, and you'll see how we address that. There are real challenges here. But let's do continue so we can get through the requirements.
Thank you.
Okay, so let's move to the next slide of general requirements. Okay, these all kind of relate. Requirement 4, any member of the general public without doing any kind of authentication or whatever ought to be able to look up a certain minimal amount of public information. What's public information? Well, whatever the regulator in that particular jurisdiction says needs to be made public. Or additionally, if an operator wants to make additional information public, we can probably accommodate that. We also need to enable in requirement 5 the lookup of private information. That, however, must be access controlled, and all the regulators have said is access controlled, but we believe that it's not just access controlled. We believe there also should be some sort of accounting and attribution and subsequent audit capability, so that you can say, well, who accessed this information and when, and what was their justification for accessing it. Requirement 6, readability. We believe the information needs to be not only human readable, which is all that's really covered by the regulators and the external standards, but also machine readable. Because if we're going to enable any kind of other applications to trigger off of remote ID data, well, then obviously those other applications need to be able to parse that data. And finally, whatever is in all these registries to be looked up needs to be put there in the first place. And there's both static information and slowly changing dynamic information that goes into registries. There's also really rapidly changing dynamic information, but we don't believe that belongs in registries. That believes in all the repositories, to which the registries would merely give you a pointer. Any questions on this batch before we move on?
Sure, here. Regarding the 6, sorry, can you hear me?
Yes, proceed, please.
Yeah, so regarding the readability, that's only considering the ID readability, or it's also including the information inside the ID, like all the aeronautical information?
I would say that it is some, but not all fields. Clearly, there will be some free text fields in there. But the ID and anything beyond the ID that is needed to enable an application to, for instance, establish contact with the operator or the operator's USS or something. I just lost the desk shared video.
Yeah. That's also one of my questions. So, and the ID message itself also containing other informations, right? Lots of the other data. Does this data also in the scope of the DRIP to be worried about?
Yes. Yeah, we're trying to address everything that's within what EASA and FAA and ASTM are calling remote ID, which goes well beyond the ASTM so-called basic ID message, which gives only an identifier and nothing more. Although the identifier obviously is the primary unique key for looking up anything beyond that. So I guess I should point out that there's two ways of getting information above and beyond the basic ID. The first way is other messages that are transmitted through the remote ID system, such as the so-called location vector message that gives, position and velocity, the operator message, the system message, and so on. But those are actually transmitted through the system. And then there's looking things up based upon a unique key acquired through the system, that being, again, the UAS ID. All right, let's move to the next batch of general requirements. Those will be 8 on, Gen 8, Gen 9. Daniel, there we go. I don't know if you can get back to slideshow mode, full screen. Still not seeing it. There we go. That's it. Okay, so now we're getting into kind of side requirements. A lot of this needs to be protected with AAA and governed by policy, and 8 is just a point that AAA itself needs to be governed by policy, and anybody who's going to edit the policy that needs to be protected with AAA. General requirement 9, I've called it finger for the moment because it feels to me kind of like the old finger service. It's obviously not. Somehow we need to be able to get some information through either broadcast or network remote ID that enables a suitably qualified observer to reach out and touch the pilot or the pilot's USS. And reach out and touch, we're not trying to constrain that. I mean, maybe it'll be a SIP call. Maybe it'll be some kind of web push notification. Don't know. But there needs to be some sort of mechanism to enable these arbitrary applications to do a kind of a reach out and touch function. And then finally, general requirement 10, quality of service. There are, in fact, performance requirements from the regulators and within ASTM that say certain messages need to be transmitted frequently, like where am I and what direction am I going? Other messages less frequently, like, what am I up to here anyway? I'm overflying this forest to look for forest fires or whatever. Any questions on this batch? Okay, next slide. This is pretty much the last of the general requirements. Obviously, unmanned aircraft move. Less obviously, ground control stations may move. Consider a delivery truck that slowly drives from neighborhood to neighborhood while unmanned aircraft lift off from the back of the truck, make the deliveries to people's porches, and then land again on the truck as it has moved half a mile down the street. That might sound implausible in the near term, but trust me, it's not. I'm involved with testing activities for major corporate clients not to be named who are doing exactly that. And other players may move as well. Multi-homing is important because unmanned aircraft, being small and flying below trees and buildings and so on, need to do frequent RF handoffs of their links. And if you want those handoffs to go smoothly, you want make before break. Make before break implies multi-homing, which also has a whole bunch of other handy benefits. Multicast. This one we get into a should as opposed to a must. Clearly, there are entities that are going to want notifications of certain things, like I'm responsible for this airspace volume, for its security, and anytime somebody reports that they are in that volume, I want to get a notification. That's an intrinsically publish subscribe kind of thing, which obviously is most efficiently supported with some form of multicast. And finally, management. If I'm responsible for a particular coverage area, then I want to know whether my network is up at the moment and really providing coverage of that area. Any questions on these? Okay, next slide. Now, this is an unnumbered at this point requirement. We probably ought to turn it into a numbered requirement or possibly a set of numbered requirements. If broadcast remote ID receivers can position and time stamp their receipt of messages, then we can do a lot of very useful things. First off, there's a kind of a fair witness concept. Well, I was in this area that nobody should have been flying in, and I received this broadcast remote ID message from, let's pick on Adam, from one of Adam's aircraft. And I assert that Adam was flying in this place where he shouldn't have been flying. Well, maybe he was, maybe he wasn't. If I was, a mile away when I received that, and then I assert that I received it in an inappropriate location, who's to say? We also obviously want to defend against replay attacks, and then there are optional supplemental data service provider services, such as multilateration, that we could support. More on that later. Next slide. Okay, now we move into specific requirements on identifiers. First off, can't be longer than 20 bytes if we're going to fit with the ASTM standard that FAA and presumably EASA are citing as an accepted means of compliance with their regulations. That identifier has got to be able to point you to which registry it's in. It's got to be, as an entity ID, requirement 3, unique within that registry that it pointed you to. And so if you concatenate 2 and 3, together they make 4. We need, within some to be determined scope, uniqueness of the identifier. And that scope is not only spatial, if you will, but also temporal. It's possible that over the course of time, an identifier might get reused. We can make the probability of that extremely low. And indeed, if we are registering each of our identifiers, as long as we keep a forever list of used identifiers, we can prohibit their reuse. And then some concept of non-spoofability, requirement 5. Now, that doesn't mean that an individual message all by itself is necessarily non-spoofable, because these messages, in the case of broadcast over Bluetooth 4, are incredibly short. But if you listen for 4 or 5 seconds and collect a batch of messages and concatenate them, correlate them in some fashion, then you ought to be able to achieve non-spoofability. Next slide. All right, this is another bunch of unnumbered as yet requirements pertaining to identifiers that we need to make a little clearer and probably number some of them. We don't want adversarial correlation. It doesn't want Amazon to know its delivery routes and vice versa. And even if we don't care about those commercial users, there are definitely government operators doing arguably legitimate things that they don't want everyone knowing exactly where they are and what they're doing. I think this next bullet is probably redundant, the whole idea of proving ownership. Then the next one's probably redundant as well, capable of verifying that messages claiming to have been sent from a given system with a given identifier really came from the claim sender. And who's going to generate this ID? Is it the operator? Is it the ground control station? Is it the aircraft itself? Is it the USS or some other registry? Or is it some collaboration amongst multiple parties? That's not specified by the regulators. Very loosely, they say, for instance, a UTM ID is assigned by the UTM system. Well, the UTM system is a large amorphous blob. What does that really mean? But there obviously has to be agreement on the identifier amongst all these identities. Any questions on the identifier requirements? Next slide. Privacy requirements. Number one, we've got to enable some form of confidential handling of private information. What do we think is private information? Well, anything that's not designated as public. And who would designate information as public? Well, either a regulator or its owner. Point two, a particular case of confidential handling is encrypted transport. There are some things like the GCS's location that are currently broadcast, well, I say currently only in prototypes and so on, because this isn't yet widely deployed, broadcast as plain text in the clear. And we obviously have the possibility that somebody will do something bad with a drone, and then somebody else will get set upon by a mob with baseball bats because they've been properly broadcasting their location while they fly. Might want to be able to encrypt that. And if we're going to encrypt it, we want to see that encryption be end-to-end at or above the IP layer, rather than depend upon, some form of security through obscurity or whatever at the link layer and below. Requirement 3, encrypted storage. This is a should requirement because it's starting to get a little beyond our world. But if we encrypt stuff only in motion and not at rest, what have we done? Probably not much. Now, satisfying all these requirements may require that authorized actors have some kind of internet connectivity. For instance, if I need to decrypt the operator's location, then I need to have a key to do that. Or somebody who does have a key needs to provide me with a key to do that. Or somebody who does have a key, presumably the USS under which the aircraft is flying, is going to decrypt it on my behalf for me. In any event, if there is a loss of connectivity to where the key is or where the decryption service is performed, then the UAS really needs to fall back to plain text transmission of safety critical information. Next slide. Yeah, so that was the last of the requirements. Any questions on the privacy requirements?
Hi, this is Sean Turner. I have a question about the one about the confidentiality at rest. It's maybe not that it's a little far afield from a transport protocol. It's a lot. Typically, we don't. So I guess I'm wondering how that's going to work out in a protocol about trying to ship things from here to there. I'm not quite sure how you're going to write that. But
Bob Moss
is a valid point.
Bob Moskowitz here. I agree with Sean. I think that one is a neat one, but that is really out of our purview.
Yeah, I hear what both of you are saying, and I agree. And yet at the same time, I'm continually frustrated by going to websites that say, oh, great, your stuff is protected. Yeah, it's protected on the wire between me and the bank. And, it's left in a leaky boathouse once it gets to the bank.
So raging agreement, I'm completely on board with you. I just think that it's going to be weird to try to have a requirement that it need it. I definitely think you can write security considerations in these documents that say, hey, look, you're a buffoon if you don't do this other thing as well. And then if we can figure out some way to point or refer to something else, I think we have a better chance of success.
I concur. Thank you. Okay,
Hi,
so
this is Alyssa Cooper. I have another question, sorry, before you move on. Just sort of at the intersection of the last two sets of requirements about the identifiers and the privacy requirements. I want to see if I kind of understand this properly, which is that the identifiers will serve as keys that exist in various registries where you can go and look up other information. But given what you said about, all having sort of a permanent record of all the identifiers that have been assigned or been seen on the network or what have you, that means that if you have temporal uniqueness, then somebody who wants to correlate a set of identifiers that all belonged to the same device over time is still able to do that because you're keeping a record forever of the identifiers that were assigned. Is that sort of like the logical result of the intersection of the identifier requirements and the privacy requirements?
yes, and that forever record would only be in the hands of the registry that accepted the operator's registration request for a particular identifier.
Here we get into the fact that it's the regulators, the CAAs, which are putting the requirements on in terms of being able to meeting their obligation to track the use of a national airspace. So in many regards, you're flying in a public space, you have to agree to a particular form of operation. And you hope that the information is properly being limited who has access to it.
Okay, thanks.
Yeah, I share your implied fear that that genie might get out of the bottle.
Well, just like thinking about what you had up there about like what's considered private information, like, normally if you're letting people specify identifiers that expire, that only have a certain lifetime, then like being able to resynthesize the fact that they all belong to the same device, like that synthesis is a piece of information that you would want to be able to maintain privately, right? So it sounds like that is possible, but getting that to actually happen in practice seems like could be hard.
Right. Yeah. The idea is that an adversary should not be able to regenerate that record from observations unless they have a ubiquitous observation capability, throughout a large area of potential aircraft operations. And, there are correlating patterns of use and so on. Whereas the registry with which I, intentionally and to satisfy regulations connected the dots between the temporary identifier and me and my aircraft, yeah, that's going to have the record. Okay, the requirements methodology input came from Dr. Gertoff. He pointed out that what we are looking at within IETF as requirements are driven by other organizations, regulators who are still working on their rules, and external SDOs who've made design choices in their attempt to satisfy the regulators. So those things are a little fluid as well. And specifically, the choice of Bluetooth and Wi-Fi. Those impose some really severe constraints that may not always apply. LDAX looks like a really nice emerging data link. And what the 3GPP people are doing under the name of 5G may come into play at some point. Andre's posting some of his thoughts on the TMRID list. And for anybody who didn't know this, we were the TMRID, Trustworthy Multipurpose Remote Identification, BOF, but we became the Drone Remote Identification Protocol, DRIP, working group. So our mailing list is still tmrid@ietf.org. So how do we move forward with the necessary speed in light of these considerations? We could focus first on what we think we know now and get something out the door, and anticipate that likely we will need to do ABIS after all the other stakeholders chime in and things settle down. Or we could take what we know now, attempt to prognosticate what's likely to happen in the future, and try to pull it off now. Are there any other suggestions on how we might, move forward on this urgent need and yet deal with these fluid requirements? And I see that Michael would like to speak.
I think you should go with the first part. I think you should go forward with the document, go through the various security and privacy reviews that will happen, and that will be valuable work, even if after that process you decide that actually you want to wait for those other stakeholders. You'll already have done that part. If you want to go to an RFC, I think you should do that, because that will be much easier to point to the other reviewer, or the other stakeholders, that this is quote real. And I don't think you'll get a response to an internet draft from some of them.
And I see our area director would like to speak.
Yeah, or mostly like a participant. Thank you for the explanation. And by the way, I agree with Michael on what Jesse said. Now, I'm more puzzled by which is the source of those requirements. Is it mainly the US FAA, or are you also putting into the mix the European EASA or others? And maybe it could be useful to mark those requirements with their source.
Yeah, I like the idea of markup with the origin of the requirement. I am most familiar with the FAA's requirements, less familiar with the EASA, but I have attempted to incorporate them to the extent I am aware of them.
So we may want to get to find someone who is knowledgeable about the European requirements, review them as well.
Absolutely. So I think we are at the last slide, if you would, Danielle.
I could just briefly say that how about interoperability with current aviation systems? I mean, like, don't you want to see a plane pilot see the drones around on the screen? So do you need the gateway, or do you need interoperability with current ADAS and systems?
Yes. The intention is not to conceal basic information such as the ID, which you can think of as a license plate number, nor the position and velocity, but merely sensitive information such as, the operator's name and current location. So yeah, clearly we want other vehicles as well as the general public to be able to see, 98% of the information that's being sent. And I see Amelia would like to speak.
Yeah, so we'll be cutting the line after Amelia.
So I hope that I can be heard. Like, I reached out to a few people in Brussels about use-based requirements, and as far as I understand, they're not adopted yet. They're in a comment period at this particular time, so it might be difficult to find EASA requirements that are fixed at this time. Like, they're still basically under development. So that's how I've understood from the European side.
Right. All we have to go on right now is EU delegating Regulation 945 and implementing Regulation 947, and some noises out of EASA on how they might go about actually implementing this. And I think there was a wrap-up slide, Danielle. Yeah, right there. So, back up one if you would, Danielle. Yeah, there we go. Do we have any requirements we should be deleting? Did we miss any? Do we have any overlaps? Do we need to restructure the way I classified it? I've got an awful lot of them that are called general that probably ought to be broken down. Ultimately, there is a call for adoption right now, which closes in May, and to which I hope many of you will respond. That would be the next slide.
Yeah, thank you, Stewart. We move now to the architectural discussion.
I just have a comment from the Jabber room. Can you hear me?
Go ahead.
Okay, so it's from Shuai Cao. He said, not sure if the KPI specified in the F3411 needs to be mentioned in the requirements.
Probably. Okay, so moving on to architecture. The point is to fit the needed functionality within the tight constraints. Next slide. Okay, I know this one's pretty dense. There are some predefined entities in this world: the unmanned aircraft, the ground control station, which together make up the unmanned aircraft system, the remote pilot, who's the guy actually at the controls, the pilot in command, who's often the same person as the remote pilot, but may be a supervisor standing over the shoulders of several remote pilots, the one who's ultimately responsible for safe operation, the operator, which is typically an organization, the USS, the network grid service and display providers, and what we call the observer. That term is not actually defined in the regulations or the ASTM F3411, but they use the term user, which is way too broad and includes way too many people without distinction. And then we're defining some things: a private information registry, a public information registry, and some optional entities. Now, the private information registry, the need for it is clearly identified in the regulations and the F3411, but what it looks like is entirely unspecified. So key point here for us is that the information required in a private information registry is a lot like what you need to register an internet domain name. And fundamentally, a UAS ID is a name. We've also got some other information that needs to go into this private registry: operator credentials, is my aircraft a multi-copter or a fixed wing, and how big is it, and things like that. Anyway, our proposed approach is to leverage all this good stuff that we have in the internet by defining a UAS ID as a domain name, perhaps only a pseudo domain rather than an FQDN, and then load up the registry with the necessary information using the typical protocols that we normally use in a domain name registration, where the UAS ID is indeed a domain. In the public information registry, this has got a lot less information, because most of the information here in the background section that needs to be made public, that doesn't just sit in a registry. That gets actually pushed out through the UAS remote ID transmission mechanisms. It's pushed out in the clear to local observers over broadcast, and it's served to clients by a network remote ID display provider in network grid, and they just point their web browser to it. So what do we really need in the public registry? Well, we need at least stuff that allow you to find the private registry. And we may need some other stuff that will allow you to find servers or services that you might want to trigger using the remote ID information that you received. Like, I don't know, make a SIP call to the pilot. So once again, let's just use the stuff that we already have. Let's use DNS. I'm not talking about defining any new weird resource record types. RFC 7484 tells you how to find an RDAP server from domain information. And whatever minimal UAS remote ID specific information doesn't fit into a standard resource record, we would expect to do the usual cheat of sticking it in a text record. And then direct machine-to-machine contact information would go in, the standard resource record types. Now, the optional crowdsourced remote ID, two entities: a supplemental data service provider that we slide in between the network remote ID service provider and display provider. It should look like a service provider to a display provider, and it should look like a display provider to a service provider. And it can multilaterate the information that it gets from the finders. Well, what are the finders? Well, they're just smartphones running an app, and they take the broadcast remote ID messages that they receive over Bluetooth or Wi-Fi, and they put a position and timestamp on them, and they relay them to that supplemental data service provider. This is an optional additional service. It goes above and beyond the scope of basic UAS remote ID, but could be really, really valuable, because basic UAS remote ID is nothing but operator self-reports. And if I'm an evil operator, I'm going to lie. And I probably, even if I'm not an evil operator, have buggy software and hardware. Next slide. Okay, these are the transactions that we presume will take place. There are a number of registration operations that need to happen. There are a number of things that would happen live post-registration. The first registration I want to point out, registry to the CAA. For this to scale up, I don't think the FAA is going to be able to pull off what they're going to pull off, which is that they run the registry. I think we're going to see the same thing we see with internet domain names. You got a boatload of registrars, a smaller number of actual registries and registry operators, and then there's a route. And the route in each jurisdiction would be the Civil Aviation Authority for that jurisdiction. Under operations, most of the ones in the middle are just standard UAS remote ID. The very first one, encrypted broadcast of personally identifiable information. That's something that we are attempting to add in the interest of privacy. Whether it really would be encrypted or not would be up to the regulator in a particular jurisdiction. And then the last couple, last three are things above and beyond that we're adding. This, finger idea of I've got a remote ID, now I can reach out and touch the pilot, and the idea of getting independent confirmation of position reports through this crowdsourced remote ID. Next slide. Okay, here's where I'd like to drill down a little bit. I have really focused on what will fit in the Bluetooth 4 constraints that ASTM has specified based upon their understanding of what FAA and EASA wanted. And the only thing I can find that fits is based upon the host identity tag, the HIT from the host identity protocol, which I know has not garnered an enormous amount of traction within IETF over the last 20 years. But there you go. To fit the ID with signatures is really hard, and to fit any kind of certificate, even using modern techniques such as EDDSA, won't fit even in the maximum 10-page message that is available to us. So our proposed approach is to adopt the host identity tag, which is a legitimate IPv6 thing, but it is not a locator, it is an identifier. It is cryptographically derived, which gives us a lot of benefits. We need to extend it to provide for a registry hierarchy. We need to ask ASTM, and we have asked them to assign a new UAS ID type, which would be presumably 4, because there's only 1, 2, and 3 defined so far in that 16-bit field, that would be specifically a hierarchical hit. Now, if they're not willing to do that, we've got tricks we can do, and I've disclosed these tricks to them kind of as a strategy to say, hey, look, if you don't go along, we're going to do it anyway, but we're going to do it in a way that's ugly. Wouldn't you rather we do it in a way that's clean? And all you need to do to make it clean is give us a UAS ID type. Beauty of this is that a self-assertion of a UAS ID fits in only 84 bytes, and 84 bytes fits in 4 Bluetooth 4 pages, which is a reasonable number to hope that you can transmit without losing a page. We can even fit a registry certificate on an air. Now, I'm using the word certificate. I know that will cause some howls from various corners. It is not an X.509 certificate. It doesn't have the flexibility of an X.509 certificate. It also doesn't have the bloat of an X.509 certificate. We can fit it in 200 bytes. That means that a maximum 10-page Bluetooth 4 message, even if we dedicate the 10th page to Reed-Solomon check bytes to recover a lost page, will fit a certificate that says, yes, this unmanned aircraft with this identifier and this public key really is in this registry. And you can verify that. Next slide. Okay, so this is a summary. Because mapping a physical location to an aircraft ID smelled like mapping a persistent host identifier to an IP address, that inspired looking at HIP, and that brought us some other benefits. So we're proposing 2 minor tweaks to ASTM F3411, which their leadership has said these should be easy lifts, but we can make no guarantees of what our committee will actually ballot in favor of. We propose some improvements to some of the HIP standards. We've got to incorporate modern crypto to make it fit, and we've got to add hierarchy to hits. Next slide. We propose using EPP, RDAP with access controls and DNS for what they're designed to be used for. And we've actually implemented more or less baseline F3411 using the open drone ID code from Gabriel Cox and Intel. as a model, wrote our own Python, prototyped some of these extensions. It's worked. We've actually flown it in the air, real aircraft. And then winter came and we stopped flying. But now we've added some code to actually do the authentication of claims in UAS RID messages, and we will fly that soon. Next slide, which I think is the last. Yeah. The architecture draft needs work. It's my own baby, and I will call it ugly. But I think it's maybe good enough to serve as a basis for group work, so maybe we want to adopt it. Next steps would be to clarify what parts of it are the pre-existing architecture into which we need to fit, what is our essential architecture for DRIP, independent of what specific protocols we might use to implement it, and what is a set of protocols that collectively could indeed implement that architecture. We've got some potential issues all involving harmonization. And that's, I think, it from me.
Thank you, Stewart. Is there any question for Stewart? We can take one or two comments or questions for him.
So Stuart, this is Eric Vink again. Do you think we could get a liaison statement from ASTM?
I will ask Gabriel, but right now ASTM is kind of lying low on this. FAA threw them a curveball with the notice of proposed rulemaking that was issued Christmas week, and FAA then got an all-time record number of comments on that notice of proposed rulemaking, over 50,000, and most of those comments were negative. So what's going to happen in the United States with regulations is very unclear, and ASTM doesn't want to do a lot of work only to then have to redo it once those regulations settle down. So they're kind of in a quiescent period right now. But I will certainly ask them.
Could be helpful.
By the way, another organization that has invited our participation is ICAO. Not with official standing, right? We can't have official standing with an ICAO. But informally, I'm now participating in one of their working groups that's involved in the so-called aviation trust framework, and we would really like to make what we do fit with that, because it is being informally said by a lot of people who should know that UTM is the future of ATM. Manned air traffic, it is very hard to make changes. Unmanned aircraft has been the Wild West up to this point, so it's easy to make changes. And what we try there, if it works, will help manned aircraft scale out for denser urban operations. So it would be really good if we align with what's going on in ICAO's International Aviation Trust Framework.
I have another question, if that's okay.
Proceed, please.
Yeah, hi. You mentioned several times the problems of message size in this context, which I can certainly understand. But then you're also, if I understand correctly, proposing to use domain names as identifiers. And I guess domain names are not necessarily the most compact identification format that we can imagine. Is there any conflict in that area in your mind?
There would be if we used an unconstrained FQDN, but what we are proposing is a HIP hierarchical host identity tag, which is 16 bytes, looks just like an IPv6 address, and is in fact carved out of the IPv6 address space. And so that can simply be stuck in .ip6.arpa for reverse lookups that can then lead to an arbitrarily ugly FQDN if somebody wanted one. Or they could actually be stuck in a forward lookup space, presumably .arrow, that would have a relatively flat hierarchy based upon the same hierarchy that's used for the hits. And I see a whole bunch of people are in the queue, so I better let you. That, Daniel.
I think, Silva, you can talk because you're the next in queue.
Yeah, just to second what Stu just said about the involvement of ICAO. I'm the secretary of the Trust Framework Study Group, and we are developing, and we have the participation of the Europeans, we have the participation of FAA, and we have the participation of aircraft manufacturers as well. So it would be good to be active there so we can develop at the same time. So we can have IETF regulations and international regulations done at the same time. Thank you.
Thanks, Sal.
So this is Adam Whitaker speaking. I just wanted to go on to the point that Ian, you mentioned for the FQDN. Stu was talking about reverse lookups, forward lookups. I've been implementing the forward lookup from the HIT, and it's just you, instead of nibble reversing everything, you kind of place the unique part and then the different parts between dot identifiers, and you get a decently short FQDN that's human readable, if you want to consider it human readable. I just thought I'd put that out there.
So one thing I'd like to mention is I think we'll continue to work on those documents, but we absolutely need some feedbacks. I mean, on the mailing list, and not only during the interim meetings. And I mean, the more organization can commit, I mean, it's the right time now. So I'm really encouraging all the people representing different organizations or that have some concerns to really mention them now on the mailing list. So it's going to come soon. The other thing I'm quite unclear, and that might be a question for Eric. Are we gonna? How are we gonna proceed? Maybe formally or informally, to get somehow an approval from those various SDOs. I mean, are we in? Is the process that we send them the document and say this is what we intend to publish, please, and we wait for a statement from them, or I don't know what's the exact procedure.
There are at least two things that needs to be done. One is that those documents that are currently personal documents should be adopted by the working group. That's the working group called for adoption. And I really encourage everyone in this call and in this working group to reply to Danielle's email on this. And the second step in it, it's not mandatory, but getting a liaison statement both ways between the IETF and this specific working group actually to the ASTM and maybe as well to FAA and ASA could be helpful, because then it validates basically the requirements that we got in the draft. So that's a two-way. So we can ask for them for comment, and then we need to check their comment back. And I can assist you on this. And typically the IEB, the Internet Architecture Board, should be put in CC in all this communication.
So Stu here. This is US only, this next comment, but ANSI, the American National Standards Institute, serves a kind of a coordinating function for many different SDOs in the US. And they have released a 300+ page document a few weeks ago, which comments are due in a couple more weeks. And I do intend to comment. Those comments will be without standing. It'll just be, you know, Stu Card's ideas. I might speak on behalf of my employer, but that would be as far as it goes. And in it, they list all the different SDOs that are at work in the unmanned aircraft systems area, and they don't list us. So I don't know what blessing we should get. Go ahead.
Us being what? IETF?
Correct. IETF is not listed, so I don't know what sort of blessing we need to get from the IAB in order to request that ANSI list us as an SDO active in this area.
Okay, let's take this as an action item. I need to leave the call in 1 minute or two for another one. And I'm not that familiar, to be honest, with all those liaison things. So let's keep talking, used to, the two chairs, myself, and we'll initiate this and keep the working group aware, of course, of the discussion.
Thank you.
Sounds like a plan. You're welcome.
Okay, so who's next?
I think we need to close the meeting, Daniel.
Med, do you want to close the meeting?
You can do it, Daniel. Right? So just yes, so yeah, please go on.
Go.
Yeah, so just this is the a reminder. What Stewart already said is that we have already ended a call for the adoption of the requirement draft. So please send your, I would say, your comments on the list and say whether you support or you don't support that document. We need more feedback from the working group to understand whether we are on the right track or not. Just right after the meeting, we will be issuing a call for adoption for the architectural document. It is not that stable. We know that, but it does not need to be stable for the adoptions, but we need to have your feedback whether this is a good, I would say, basis and starting point to work on the architecture. And for the others, I think that's, yeah, please, we are seeking for feedback, and the more we get feedback now and concerns about the approach which is done by the working group, this will be really useful for us, because we need to scope the work, and also I would say to have more, I would say, coordination with the other organizations who are doing, we are working on this area. So please reply to, I would say, to the list and send your feedback there. Thank you. I think that we are now at the end of the, I would say, of this meeting. So thank you all for participating, and I think that we can adjourn and talk to you next time.
Thank you very much. So please, if you haven't signed the blue sheet, sign them now. Thank you all. Bye.
Thanks, Daniel. Talk to you later.